Hello everybody, welcome to NEET Physics by Arun channel. In today's video, we are going to see an MCQ in the chapter Atomic and Nuclear Physics. What is the questions are? Let us look into the question. Match list 1 with the list 2. Choose the correct answer from the options given below. What are the options? It is coming in the next slide. This question has been asked in the NEET examination in the year 2024. So, last year. Okay. What the table tells us. List 1, spectral lines of hydrogen for transition from this to this, this to this. List 2, their wavelength, the corresponding wavelength emitted during the transition. Wavelength of light or any radiation. Okay. So in A, we are giving the energy transition from which orbit to which orbit. Here from 1 to 4, it has been you are given the wavelength in nanometer. But the wavelength are not in order. 410, 434, then 656. Then once again decreasing, 486.4. What is the correct order that you have to find? Okay. So, you know that when an atom goes from an excited state, from a higher state to a lower state, it emits energy. This is called transition energy. This transition energy is given by delta E is equal to h nu, which is equal to hc by lambda. Okay, that's all. So the transition energy will be lesser if the difference between the upper state and the lower state is minimum. It will be larger if the difference between the two states is maximum. In that sense, here all the lower states are only 2. All the lower states are 2 only, and the upper state is different for different cases. For A, the upper case into is 3, then one is the lower state. For B, it is 4, for C, it is 5, and for D, it is 6. So, automatically, naturally, you know, the energy transition will be greater in the case of D. That is from N2 is equal to 6 to N1 is equal to 2. So, atom is going from the N2 state to the N1 state. So, this energy transition will be somewhat lesser when it goes from 5 to 2. Still lesser when it goes to 4 to 2. Still lesser when it goes to 3 to 2. In order to understand this concept, I have given you the what is this energy level diagram. This is not the same. This figure does not represent the case in your question, but this figure will be useful to understand this. So this is n is equal to 5, 5 to 1, this is large energy. This is n is equal to 4 to 1, somewhat lesser. 3 to 1, still lesser. 2 to 1 is still lesser. So this is the lowest energy, and this is somewhat higher energy, and this is the highest energy. Okay. So what are the options that you are given here? A to 2, B to 1, C to 4, and D to 3. Option 2 is A to 3, B to 4. In such cases, you are given 4 different options. Then how to find the correct answers? See, so already I told you that energy difference delta E is equal to hc by lambda. Delta is equal to h nu, where nu is equal to c by lambda, so hc by lambda. That is already studied. So that means what? If you bring lambda to that side and delta to this side, you will get lambda is equal to hc by delta E. It means what? Lambda is directly proportional to 1 by delta E, or you can also say lambda is inversely proportional to delta E. Transition energy, change in energy. Okay, transition energy. So already I told you that this transition energy will be very much greater where the transition takes place between the lowest state and the highest state. So 6 to 2 from and from n is equal to 6 to n is equal to 2, you will get the maximum transmission energy. For 5 to 2, it will be somewhat lesser energy. For 4 to 2, it will be still lesser. And for 3 to 2, you will have the lowest transition energy. So, in the case of lambda, the reverse will happen. So, delta E is the lowest for 3 to 2 and lambda will be the greatest for 3 to 2 transition. So, lambda 3 to 2 will have maximum wavelength and 4 to 2 will somewhat lesser wavelength and 5 to 2 will have still lesser wavelength and 6 to 2 will have will be the lowest wavelength. Okay, that's all. So 656.3 for 3 to 2, 486.1 for 4 to 2, 434.1 for 5 to 2, and 410.2 the lowest wavelength for 6 to 2 transition. So in that sense, A for 3, B for 4, C for 2, D for 1 is the second option is the right answer. Okay, hope you understand this problem very well and you will do it in your examination. Okay, so we will see some other question in some other video in this chapter, atomic and nuclear physics. Till then, thank you one and all.